So have you ever written a cool little script and thought, man, I wish my AI could just use this? How do you actually take a simple function on your computer and turn it into a real, secure tool that any AI can call from the cloud? Well, that's exactly what we're going to do. We're going to go on a step-by-step journey turning a local Python script into a fully deployed AI tool with Amazon Bedrock AgentCore. It really all boils down to this question. An AI model, for all its power, is kind of stuck in its own digital world. If it wants to do anything useful, like check a real-time inventory, process an order, or even just fetch a current weather report, it needs a bridge to the outside world. And that's what tools are. Our job today? It's to build that bridge, and to do it in a way that's secure, standardized, and reliable. Okay, so to kick off our journey, we first have to get our heads around the big idea that makes this all possible, the MCP server. You can think of this as the digital workshop where we're going to build and organize all the tools for our AI. Now, this right here is the key concept, MCP, which stands for Model Context Protocol. If our tools are the equipment in that workshop, MCP is like the universal instruction manual. Now, you might be thinking, hey, why can't I just use a regular old REST API? And that's a fair question. But the real magic of MCP is that it's built for more than just calling a tool. It's designed for discovery. It lets an AI ask, hey, what can you do? And get a perfectly structured answer back. That's absolutely crucial for building truly smart, autonomous agents. One of the first and most important choices you'll make is whether your server is going to be stateless or stateful. A stateless server is basically like a vending machine. You put in a request, you get a result, and that's it. The machine forgets you were ever there. It's perfect for simple, one-off tasks. A stateful server, on the other hand, is more like having a real conversation. It remembers what you talked about last. This is totally essential for more complex tools, where you have a multi-step process or a back-and-forth interaction. All right, enough theory. It's time to roll up our sleeves and get our hands dirty. For any project like this, the first, most critical step is always to build and test everything in a safe local environment. We don't even think about the cloud yet. And here's our roadmap for the rest of this explainer. It's a really straightforward 4-step process. Create, test, deploy, and invoke. We're going to write the code, make absolutely sure it works on our own machine, then push it up to the cloud, and finally, call it like a real live service. So let's jump into step 1, create. The whole process starts with what is honestly surprising simplicity. This one line of Python code, that's the entire foundation of our tool server. We're just creating an instance of fast MCP, and you can see we're setting it to be stateless, which is perfect for the simple tools we're starting with. And this is where the magic happens. How do you take a perfectly normal Python function and turn it into something an AI can actually find and use? You just add this one little line. It's called a decorator, right above your function at micp.tool. This basically tells our MCP server, hey, this function right here, it's a tool. Make it available to the world. It is literally that easy. So once we've defined all our tools, we need to actually start the server up. And this line, mcp.run, well, that's what flips the switch. It takes all the functions we decorated, bundles them up, and makes them accessible over the network using standard HTTP. It's now live and ready for us to test. Before we move on, I really want to stress why we test locally first. Trust me on this. It is fast, it is free, and it will save you a world of headaches down the line. You can find and fix bugs in seconds instead of minutes or hours, all without racking up any cloud bills or wrestling with deployment issues. You just run your script and you use a client to poke at it and make sure it does exactly what you expect. Okay, so our tool works. We've tested it. Now for the really exciting part. Taking it from our humble laptop and making it available to the entire world by deploying it to the AWS cloud. So you're going to run a single command, AgentCore deploy. But what is actually happening behind the scenes? Well, this slide breaks it down. That one command is like a Swiss Army knife. First, it packages up all your code and its dependencies. Then it uploads that package securely to the cloud. After that, it provisions a brand new dedicated environment just for your tool. And finally, it deploys your code to that runtime. It literally handles all the heavy lifting and infrastructure work for you. Now, before you can hit that deploy button, you just need a few things in place. Think of it as a pre-flight checklist. You'll need an AWS account, of course, a modern version of Python, the AgentCore command line tool, and a properly set up project folder with your server script and a file listing its dependencies. It's just a simple checklist to make sure your deployment goes off without a hitch. And just like that, our tool is live. But you know what they say, with great power comes great responsibility. A tool that's accessible from anywhere on the internet has to be secure. So how do we make sure only the right people or the right applications can actually use it?
If you try to call your brand new tool right out of the box, you're going to run into this brick wall, a 401 unauthorized error. And you know what? This is a good thing. It means the system is secure by default. It's like a bouncer at a club demanding to see some ID before it lets you in.
The solution to our unauthorized problem is something called OAuth 2.0. Now, don't let the name scare you. The best way to think about it is like a valet key for your app. You wouldn't give a valet the master key to your house, right? Instead, you give them a temporary key that only works for your car. OAuth is the same idea. Your app goes to a trusted authority to get a temporary access pass, or a token. It then shows that token to your tool server to prove it has permission. It's super secure because the token expires and your main credentials are never exposed. And here's how that whole digital key system works in practice. First, you set up what's called an identity provider. Then, your client application goes to that provider to get its temporary token. With the token in hand, it makes a request to your tool, but it includes that token in the request header. AgentCore sees the token, automatically checks if it's valid, and if everything checks out, it lets the request through to your tool. Simple as that. Okay, we are in the home stretch. We've built our tool, we've tested it, we've deployed it, and we've locked it down. Now for the moment of truth, actually using our live, cloud-hosted AI tool. The cool part is that calling our remote tool is almost identical to how we tested it locally. The client code barely has to change. The only real difference is that now our client needs 2 extra pieces of information to find and authenticate with the server way out there in the cloud. And these are the 2 secret ingredients, the agent ARN and the bearer token. Just think of the ARN as the full, unique mailing address for your tool server in the vast city that is the AWS cloud. It tells the client exactly where to send the request. And the bearer token? That's the temporary access pass we just talked about, proving it has permission to be there. Give your client these 2 things and you're in business. And with that final successful connection, you've done it. Seriously, take a second and think about the whole journey. We started with just a few lines of Python code on a laptop, and now we have a robust, secure, and globally accessible endpoint. You've literally given an AI a brand new skill. So there you have it. We've walked through the entire process, from a simple idea to a live AI tool. You now have the blueprint to give an AI any skill you can possibly imagine and write in code. So really, the only question left is, what are you going to build next?